Hi all, welcome to the next lecture on Z transform. We are dealing with properties of Z transform in this video. Okay. Let us write down the properties and keep first. First is linearity property. x1 of n plus x2 of n. Z transform is x1 of z plus x2 of z. As in Laplace, Z transform also will have ROC, and this ROC will be intersection of individual ROCs of x1 and x2. Let us say R1 and R2. Next property is time shifting property. X of n minus n naught, Z transform is z raised to minus n naught x of z. The ROC is the same as x of n. So, what is this R? R is the old ROC, that is the ROC of x of n. Okay. Time scaling is the next property. X of n by k as a Z transform, x of z raised to k. ROC for time scaling is, the ROC for this case is r raised to 1 by k. We will see what is this. Fourth property is scaling in z domain. Alpha raised to n x of n as Z transform x of z by alpha. Alright, and ROC for this case is alpha r. R is the original ROC of x of n. The ROC of alpha raised to n x of n is alpha mod alpha into r. Next property is time reversal property. X of minus n as a Z transform x of z inverse, that is x of 1 by z. ROC for this is 1 by r. So, r is the original ROC of x of n, the ROC of x of minus n is 1 by r. Next property is differentiation in z domain. N of x of n gives us minus z d by dz of x of z. The ROC for this case is r. Next property please, convolution in time property. X of n convolved with h of n is x of z into h of z. Okay. Convolution in time domain is multiplication in the z domain. Fine. ROC for this case is R1 intersection R2. R1 is the ROC of x of n, R2 is the ROC of h of n. The combined ROC of the convolution is R1 intersection R2. Okay. Now, we will solve sums on these properties and see how to use these properties for our sums. First sum please. Y of n is equal to alpha raised to mod n, where alpha is less than 1. Alright, and we have to find Z transform. Alright, let us start off by understanding this mod n. Right. So, mod n, if the value of n is positive, you will get a positive value. If the value of n is negative, you will still get a negative value. So, I can write mod n as n. Alright, this is for n more than or equal to 0. Value of mod n is equal to minus n. Alright, for value of n less than 0. Just understand this. If value of n is less than 0, this for example, if n is minus 2, the value of mod n is minus 2, that is plus 2. Right? So, mod n gives you positive values. So, the meaning of mod n is, value of mod n is n for n more than or equal to 0, and the value of mod n is minus n for n less than 0. With this basic understanding, let us start off with this sum. we'll say therefore y of n is equal to alpha raised to n for n more than or equal to 0 and y of n is equal to alpha raised to minus n for n less than 0. Right. So, I hope these two things are clear. Once it is clear, we can start off with the sum. Alright. So, y of n is equal to alpha raised to n for n more than 0. So, what is the meaning of n more than or equal to 0? It means the positive axis, right, causal system, right, that is u of n. And what is alpha raised to minus n? It is the negative side. In Z transform, we will see it as u of minus n minus 1, right, we have seen these properties. Therefore, I can say, therefore, y of n is equal to alpha raised to n u of n plus alpha raised to minus n u of minus n minus 1, right. So, my sum now is in this way over here, this is my sum and this was the earlier sum. Now, we have expanded that to get into this form, okay, and we can apply which property over here? The linearity property, fine, okay. So, we have seen some standard signals. The standard signals were a raised to n u of n, the Z transform is 1 upon 1 minus a Z inverse, and a raised to n u of minus n minus 1 minus of Z transform is again 1 upon 1 minus a Z inverse. Alright. Here the ROC is mod Z is more than mod a. Here the ROC is mod Z is less than mod a. Alright. So, we will apply these properties over here, these standard values or standard signals over here to find the value of the Z transform. From our earlier slide, we have y of n is equal to alpha raised to n u of n plus alpha raised to minus n u of minus n minus 1, alright. That is same as saying alpha raised to n u of n. This is in a standard form, a raised to n u of n, I can get the Z transform properly, but this is in a form a raised to minus n, right, a raised to minus n u of minus n minus 1. So, I have a raised to n over here. How do I get this? How do I get this n as positive? Here it is negative. What do? I will take the minus sign inside. I will take the minus sign inside. So, I will have 1 by alpha raised to n u of minus n minus 1. So, I can write alpha raised to n u of n minus of 1 by alpha raised to n u of minus n minus 1. Okay. The Z transform of this is y of z is equal to alpha raised to n u of n, a raised to n u of n. So, what is comparing this and this? What is alpha? Alpha is a. And over here, alpha raised to 1 upon alpha raised to n u of minus n minus 1. If you compare this with this, what is the value of a? This is the value of a. A is 1 by alpha. Fine. So, alpha raised to n u of n will give me a Z transform as 1 upon 1 minus a. A is alpha. Alpha Z inverse minus 1 upon 1 minus a. A over here is 1 by alpha. 1 by alpha Z inverse. Therefore, I can say y of z is, if I take Z inverse, I can say Z upon Z minus a minus Z upon Z minus 1 by alpha. So, that is the Z transform y of z. Fine. Okay. So, now we have found the Z transform. Y of z is equal to Z upon Z minus alpha minus Z upon Z minus 1 by alpha. Now, we should find the ROCs. Okay, ROCs. So, ROC of this Z upon Z minus alpha is mod Z is more than mod of A, that is mod of alpha, and over here the ROC of this is mod Z is less than mod of A, that is 1 by alpha. Why is this less than? Because it comes from u of minus n minus 1. U of minus n minus 1 gives us less than, u of n gives us more than. Alright. Now, if you see the sum properly, in the sum it is given that this alpha, mod alpha value is less than 1. What is the meaning of that? Alpha is between minus 1 and 1. Okay. So, alpha is between minus 1 and 1 given to us. So what does this mean? If I say mod z is more than alpha, this alpha over here is between -1 and 1. Alright. So if I draw the ROC z plane, please. This is real part of z. This is imaginary part of z. I will draw the unit circle. So radius of this is 1. This over here is my unit circle. If I say mod z more than alpha, what is alpha? Alpha is a value between -1 and 1. Okay, so what are my poles from this equation? Poles. Pole is z is equal to alpha. And what is the next pole? Pole is z is equal to 1 by alpha. Okay, where do I plot z is equal to alpha? Somewhere over here, right? Z is equal to alpha. But what is the condition over here? That alpha is between -1 and 1. Okay, it is less than 1. Fine. So alpha is over here. So I can say a pole over here, alpha. So I say alpha is between -1 and 1. So if I say alpha is equal to half, what is 1 by alpha? 1 by alpha is equal to 1 upon 1 by 2, that is 2. Fine. So 1 by alpha will be outside the unit circle. Alright. What is the first ROC say to us? Mod z is more than alpha, means it should be like this, right? More than alpha. And what is the meaning of mod z less than 1 by alpha? Alright. Now, this ROC, let us plot the ROC. Mod z is more than alpha means this region. And what is mod z less than alpha? It is this region. So this over here is alpha. So this is my ROC. So what is my combined ROC, please? Combined ROC is mod z is more than alpha less than 1 by alpha. This is my final ROC. So whenever you do sums on Z transform, you should take care that you find the final answer, Z transform answer, and also you plot the ROC. So this is the final ROC which we have plotted. Fine. That is sum number 1. Sum number 2, please. Y of n is equal to -1 by 6 raised to n u of n plus phi 1 by 3 raised to n minus of u of minus n minus 1. Find y of z and the ROC. Alright, this is a straightforward sum. What is y of z? Therefore, y of z is equal to a raised to n u of n. Okay, what is a raised to n u of n? So, what is the value of a over here? A over here value is -1 by 6. A raised to n u of n. A raised to n u of n is 1 upon 1 minus a. A is -1 by 6. A z inverse. And over here it is a raised to n u of minus n minus 1 minus. Okay, so, it is the second formula. So, answer this is 1 upon 1 minus a. A is a raised to n. A is 1 by 3. Z inverse. Okay, and don't forget this phi. So, I will add the phi over here. So, I can add this as z upon z minus z plus 1 by 6 plus phi z upon z minus 1 by 3. The ROC over here is mod z is more than mod a. What is mod a? -1 by 6. And what is ROC over here? Mod z is less than, right? 1 by 3. Why do we have a less than over here? It is because of this u of minus n minus 1. Why do we have a more than? It is because of this u of n. Mod z is more than 1 by 6 minus 1 by 6 and mod z is less than 1 by 3. Okay, let me draw the z plane, please. Mod z is more than 1 by 6, minus 1 by 6. So, where is my pole over here? It is at minus 1 by 6. So, where is minus 1 by 6? Maybe somewhere over here. This is 1, this is minus 1, right? So, minus 1 by 6 is somewhere over here. Minus 1 by 6. And what is 1 by 3? It is somewhere over here, by 3. Mod z is more than minus 1 by 6. So, how is it going to be like? Something like this maybe. And mod z is less than 1 by 3 means something like this. Okay. So, mod z is more than 1 by 6 means this region entirely, and mod z is less than 1 by 3 means this region entirely. So, what is the combination of both? The combination of both is just this intersection point over here. So, this over here is your ROC. What is the meaning of ROC? ROC means the region at which your Z transform exists. Fine. So, whenever you do sums on Z transform, do not forget to do sums and get the Z transform, also get the ROC over here. Sum number 3 please. Y of n is equal to minus 1 by 3 raised to n u of minus n minus 2. Find y of z. Fine. So, in the earlier two sums which we had seen, this is property number 1 please, linearity property. Now, we are seeing next property, that is time shifting property. So, time shifting property says to us that x of n minus n naught Z transform is Z raised to minus n naught x of z. Fine. So, how do I solve this now? We will use the let and now method. So, we will first write the known and then the unknown. So, we will first write the known. Let y1 of n. Okay. What is the known over here? We can write known as a raised to n u of minus n minus 1, right? We can write that. So, we can say minus 1 by 3 raised to n u of minus n minus 1. We can put extra minus sign just for our convenience. We know the z transform of this, right? This y1 of z is 1 upon 1 minus a is minus 1 by 3 z inverse. How did we get this? The formula is minus a raised to n u of minus n minus 1. Z transform is 1 upon 1 minus a z inverse. Okay, we have used this formula. So, what is the answer of y1 of z? 1 upon 1 plus 1 by 3 z inverse. So, that is my y1 of z. So, this is the known thing. So, I have got my known thing over here, y1 of z. Next step is, we will find the unknown. Now, what do we do now? The unknown in terms of known. Right? So, I will say y of n is my question, right? Minus 1 by 3 raised to n u of minus n minus 2. And what was y1 of n? y1 of n was minus 1 by 3 raised to n u of minus n minus 1. So, this over here is your unknown and this over here is your known. You need to get unknown in terms of known. Right? Let us see how do we do this. We can write this as minus 1 by 3 raised to n u of, okay, I can make this minus 2 as minus n minus 1 minus 1. Anything wrong? No, right? Minus 1 by 3 raised to n u of minus of n plus 1 minus 1. No change, right? Minus n minus 1, same thing you will get again. So, what you are seeing, something is developing right over here. So, it is minus 1 by 3 raised to n u of minus n plus 1 minus 1. Alright. If I can write this as this way, minus 1 by 3 raised to n plus 1 u of minus of n plus 1 minus 1. What have I added extra over here? Plus 1 over here. How do I negate this? I will add a minus 1 by 3 raised to minus 1. If I combine this and this, again you will get back the same thing. So, what do you see over here? You are seeing that the term has come like this. Minus 1 by 3 raised to n plus 1 u of minus of n plus 1 minus 1. Alright, let us check it over here. If I just replace n as n plus 1, what do we get? y1 of n plus 1 is minus 1 by 3 raised to n plus 1 u of minus of n plus 1 minus 1, right? So, if we replace n as n plus 1 in y1 of n, we will get this term. So, this entire thing can be replaced by y1 of n plus 1, and this minus 1 by 3 will become minus 3. So, we have got y of n as this. So, what is the z transform? Y of z is equal to, what is y1 of n plus 1? Answer is z raised to minus of n naught. What is minus of n naught? Minus 1. y1 of z into minus 3. So, what is final answer? Minus 3 z to the power 1 y1 of z. What is y1 of z? y1 of z was 1 upon 1 plus 1 by 3 z inverse. Alright. So, therefore, you can say, therefore, my answer I of z is equal to 3 z inverse 1 plus 1 by 3 z inverse. So, this over here is my y of z, not z inverse, z, okay. And what is ROC of this? We have seen the property, right? Property says ROC is same as the earlier ROC. So, the earlier ROC should be for this term, right? A raised to n u of minus n minus 1. So, the ROC is going to be mod z is less than A. What is A? 1 by 3. Let us draw the ROC, please. Unit circle over here. Where is your pole? Pole is at minus 1 by 3. This should be minus, right? Yeah. This is minus 1 by 3. Mod z is less than minus 1 by 3. Means it should be something like this. So, this over here is your ROC. I hope you understand why minus, because it is 1 minus 1 by 3 z inverse. So, A over here is minus 1 by 3. That is why you have written minus 1 by 3 over here. Right? This is the ROC for the sum number 3. Right? So, this is your Z transform answer, and this over here is your ROC answer. Fourth sum, x of n is equal to 1 for 0 more than less than equal to n less than equal to 5 and 0 elsewhere. If g of n is equal to x of n minus x of n minus 1, find g of z. Okay, very easy sum. X of n. Okay, what does I say x of n is? X of n means x of n. They are saying x of n is equal to 1 for what values of n? 0 to 5. So, I will have values 0, 1, 2, 3, 4, 5. What are the values of x of n? It is 1 throughout. 1 and 0 elsewhere. So, all of the parts 0. What are they saying? They are saying that g of n is equal to x of n. This is x of n minus x of n minus 1 minus of x of n minus 1. What is x of n minus 1? X of n minus 1 is going to be right shifted x of n. Okay, so shift this to the right by 1. So, we'll have 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6. One more sample over here, right? So, it will start from 1, 2, 3, 4, 5 and 6. So, what is x of n minus x of n minus 1? What is going to be the final answer of this? X of n minus x of n minus 1. X of n minus of x of n minus 1. So, 1 minus 0 is 1. 1 minus 1 is 0, 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 and then at 6, 0 minus 1, what is that? At 6, 0 minus 1 is minus 1, right? Don't forget this, don't skip this out. So, g of n is given as x of n minus x of n minus 1. What have we found out g of n as? It is a impulse at 0 and an impulse at 6, but it is transformed across your x-axis. So, how does this transformation across the x-axis happen? When you multiply your impulse by 1. So, this is your delta n, right? Impulse at 0. So, delta n plus, what is this sample? This is a shifted impulse, shifted by delta n minus 6, right? So, delta n is this sample, delta n minus 6 is this sample, but this is transformed across the x-axis in this way, that is multiplication by minus 1. So, if you multiply this signal minus 1, you will get a reversal across your x-axis. So, you have to multiply it by minus 1. So, what is g of n? G of n is delta n minus delta n minus 6. Therefore, this is your g of n. Okay. Very easy. What is z transform? G of z is equal to, what is delta n z transform? 1, right? What is delta n minus 6 transform? Z raised to minus of n naught. N naught is 6. What is the delta n transform? It is 1. So, answer is 1 minus z minus 6. Alright. And what is the ROC? ROC is the entire z plane. Why? Because this g of n is a finite duration signal. Next sum please. X of z is equal to z cube minus 2z upon z minus 2 and y of z is equal to z upon z minus 2. Alright. It is saying get x of n in terms of y of n, and it is saying y of n is a right sided signal. So, it is saying to us that we have to find x of n in terms of y of n. Let us start off with y of n first. Okay. How do I find y of n? What is given to me? Y of z is given to me as z upon z minus 2. And they have said that z of n is right sided signal. Okay. So, that is a clue. So, what is y of n therefore? A raised to, what is a? 2. 2 raised to n u of n. Why is it not u of minus n minus 1? Because it is given u of n is right sided. Therefore, y of n is 2 raised to n u of n. Fine. So, I have got this. This is my first. Y of n is equal to 2 raised to n u of n. Alright. Now, next. X of z is given as z cube minus 2z upon z minus 2. Okay. I can expand this. Z cube upon z minus 2 minus 2z upon z minus 2, right? Now, how do I reduce this so that I can get some answer? What do? I know the z transform of a raised to n u of n. It is what? It is z upon z minus a, or it is 1 upon 1 minus a z inverse, right? So, z upon z minus a is what I know. So, I don't have z upon z minus a directly. So, what do I say? I will take one, I will write like this, z square z upon z minus a. I have taken that 1z, I have blended that 1z over here, and minus 2 z upon z minus 2. 2. Alright. So, that is your x of z. So, z squared into z of z minus 2 minus 2 into z of z minus 2. Now, what is this z of z minus 2? Z of z minus 2 is your y of z, right? You can see that given to you. Z of z minus 2 is y of z. So, I can say this is z square y of z, right? Minus 2 y of z. X of n then. X of n will be given by inverse z transform. Okay. When do you get z square y of z? When you get z square y of s, we are doing the property, right? What does the property say to us? Z square. When do I get z squared y of z when n naught is equal to minus 2, right? So I can say I have y of z inverse is y of n, right? So y of not just y of n, since I have this z squared, so n naught is minus 2, so minus of minus 2. So y of n minus minus 2 gives us z squared y of z minus 2 y of n. That is y of n plus 2 minus 2 y of n. So I have got x of n in terms of y of n. Okay. So x of n is y of n plus 2 minus 2 y of n. And I found out y of n earlier. Y of n is 2 raised to n u of n. Y of n is 2 raised to n u of n. So what is y of n plus 2? 2 raised to n plus 2 u of n plus 2 minus 2 into y of n is 2 raised to n u of n. So this over here is my final answer. So x of n in terms of y of n is this, and x of n, the correct answer is this over here. Okay.